Hey everyone, welcome to another Open Cluster Management Community meeting. Today is August the 2nd, 2024, and today Quinn Howe is going to share a little bit about the enhancement that has been merged, I think, on the add-on configuration, allowing users to configure multiple configs for the same GVK. Quinn Howe, please feel free to take it away whenever.
Okay, thank you. Let me share my screen. Okay, hello everyone. Today I want to share some new updates on the Addon configurations. This is a new proposal about to let Addon configuration to support multiple configs with same GVK. The goal is that we want enable user to configure multiple config of same GVK in both the CMA and MC. First, let me introduce some current situation. Currently, user can have 3 locations to define their add-on configurations. They can either define a configuration in the cluster management add-on. In the spec.supported config, user can define a default config as a global config for all the add-ons on all the clusters. And also, user can choose to define the configuration in the CMA in the spec.install strategy .placement.config. User can declare some configurations for a group of clusters selected by the placements. And also, user can choose to define the configs in the managed cluster add-on. In that way, user can define a config for the add-on on a specific cluster. And currently, since we only for each GVK, we only support 1 config. So even user define multiple configs in either place 1, 2, or 3, only one will take effect. And if they define the same GVK configuration in different location, there is an override sequence. The config in place 3 will override the configs in place 2 and override the config in place 1. I will use our current stock as an example. In the add-on configurations, you can see in the default configuration, in this example, user defined a add-on deployment config named the default deploy config. Where this defined all the add-ons on all the clusters will use this config. And if they also define the add-on deployment config in the install strategy level, like this example, besides define a default config, they also define a install strategy level config in that way. So the clusters selected by the placement will use deployment config, and the rest cluster will still use the default deploy config. And last is that user can also define some configs in the managed cluster add-on for a specific cluster. In this example, user can define a deployment config named the cluster 1 deploy config only for cluster 1. And in this way, the cluster 1 will just use the cluster 1 deploy config. And this will override both the install strategy level config and the default config. Okay, this is the current override sequence. And the requirement is that we are seeing some requirements to set multiple configs for the same GVK. For example, for the observability add-on, they use OpenTelemetry collector as their config, and user may want to define 2 OpenTelemetry collector in the install strategy level. There will be one here configured to collect the traces and another to collect the logs on the same cluster. So this proposal aims to satisfy this requirement. The goal for this proposal is that we want to enhance the current CMA and MCA API to allow user to configure multiple add-ons with same GVK. Another goal is that for the default config, we do not expect user to define multiple configs with same GVK currently. So the goal is in place 2 and 3, we want to support user define multiple configs with same GVK. Next are some details. For the API level, since both the install strategy level config and the MCA config, they are using the same data structure, and the config is actually an array. And we do not do any check from the CRD level. So user can define multiple configs with same GVK today. The difference is that today, since we only support one config, so even user define multiple, there will only be one take effect. So for the API, there is no change. And for the effective add-on config, as I mentioned, today there will only be one effective add-on for each GVK. But the change will be that since we are going to support multiple GVK and multiple config with same GVK, we can no longer use GVK as the identifier for each config. And instead, the GVK plus a name and namespace becomes the identifier for each config. So we need to reconsider the logic to set the effective add-ons, which will be put into the mca.status. And in the initial discussion, we discussed many possibilities of how we can handle this case. And finally, we choose the option called override by GVK as our solution, as it better satisfies the real use case. And the other two alternatives are listed in the end of this talk. I will introduce both of them today. Okay, before I introduce it, let's see an example. This is an example that I omit the group and namespace. This is an example that user define multiple configs for same GVK. Or in the supported config, you can see there is a default config for resource R1 named N1, and there is also a resource R2 without default config. And in the install strategy level, it defined a R2N1 and R2N2. This is the multiple config case. And also in the manage cluster add-on, also define a R2N3. This is for a specific cluster. So when user define both of them, let's see how the effective add-on configs work. I will keep the example. I will keep the example here. For the option to override by GVK, this is a way that we try to keep consistent with current behavior. We still use GVK as the identifier, but it is for a group of configs. And with this strategy, in this example, for R2 resource, since user define a R2 and 3 in manage cluster add-on in place 3, it will override the R2N1, R2N2 configs. And also since there is, that's the override sequence for R2. So R2 and 3 will take effect. And for R1, since there is no other R1 resource defined in install strategy and MC, so R1 will still take effect for cluster 1. And the final result will be R2 and 3 and R1 and 1. This is the result when we use GVK as the identifier for a group of configs. And the limitation for this case is that you can see in this example, if user want to treat R1, R2N1, R2N2 as a global config and want to reuse it in cluster 1, in this case, since they defined N3, so it will be override. If users still want to use N1, N2 in cluster 1, they need to write both of these 3 configs in cluster 1. This is a limitation. Okay, I will go to the bottom of this proposal, introduce another 2 options. The second option is we have considered to use GVK and place name, a namespace and name as the identifier for each config. In this case, since GVK and namespace and name is the identifier, you can treat every config is different. So there is no override concept anymore. All the configurations will be listed in the status. And there will be the config will be ordered. The MC config will be on top of CMA, and the configs with higher index will be on top of the one with lower index. Like this. Still use the example on the left. If we treat every config is different, so all the config will list in the status. That is R2N3, R2N2, R2N1, and R1N1. They will all be listed in the status. The disadvantage for this option is that for some add-ons, they may feel it's hard to differentiate whether the config comes from the CMA or MC. So they feel hard to use this option. And the last option is for override. Override is just straightforward. So any config in MC will override the config in install strategy and override the config in default. Still in the example, in this option, there will only be R2N3 listed in the status. Okay, that's the 3 options the initial discussed, and finally we choose to use grouped override by GVK. And there is a limitation need to take care. Okay, so when close this. And when there are effective add-on listed in the status, how should add-on use the config values? For the effective config values, currently it depends on how user implement the with get values function. Or for example, for the add-on deployment config, the get add-on deployment config values, it just goes through all the CMA.status list and just read the last object. So for add-ons who want to use multiple configs for same GVK, they need to implement their own with get values func and determine how they use the multiple configs. And the last thing is how to trigger rollout. As you know, today the add-on rollouts are triggered by configuration change. So when we support multiple configs with same GVK, both the build configuration graph stage and set route status stage and generate route result stage, we need to change some logic. Previously we use GVK as a key and just compare the GVK. But when with this change, we also need to compare the namespace and name to ensure GVK as a key, there is a group of configurations in the graph and route results. Okay, I think that's all for the change. Any questions, especially for the override strategy? Okay, if now we have a PR in the OCM repo. If you have any question, feel free to give some comments. It's still work in progress. I think most of the tests are passed.
Yeah, I think we also need to update the doc on the website on the change
Yes.
after that PR is merged.
Yeah.
Well, so just to confirm, there won't be any like compatible issue with the old version of OCM with newly version of Addon framework, or maybe it's not a valid case, but with old version of Addon framework and newly version of OCM, there won't be any compatible issue, right?
Yeah, from the test case, I did not change the existing test case, so I suppose there is no impact. I just add some new case.
Got it. Thank you.
Okay, thank you. That's all for my part. I will stop sharing.
Thank you, Kunhao. Thank you, Kunhao, for that presentation. Are there any other questions for Kunhao and comments? If not, Qiuzhen, do you want to, since we have a little bit of time, do you want to talk a little bit about the EKS enhancement proposal that was just merged today, I think? Not
yeah.
the EKS as a hub cluster enhancement.
Yeah, sure. Let me find the proposal. You can see my screen.
Yes, we can.
Cool. So yeah, so this is this one is about to using the AWS IAM as the registration process instead of using the CSR. So we previously we have we know that we basically rely on the kube CSR mechanism to do the registration, but that does not work in the EKS because EKS doesn't support kube client type, a CSR with kube client type. So this one is a proposal that by the by not by me, but by other authors in the guideware who try to using the leverage the AWS IAM to do the EKS registration. So there are some assumption. So the first assumption is that in this proposal, we assume that both the hub cluster and the managed cluster are all EKS clusters. So certainly if the hub is not EKS, we don't really need to be able to use that. But in this proposal, we also require that the managed clusters are also EKS clusters, so we can so they can use the STS mechanism in the EKS to do the registration. So here is some goals and non-goals. So goal is to run the hub in the EKS, and also we will enhance the class ADM command line to provide EKS-based AWS IRSA-based registration. The whole strategy, the registration strategy is pluggable. So which means that we should be able to support CSR and AWS-based registration at the same time on the hub, and agent can either use CSR-based or other-based registration mechanism. So currently, we refactor the whole registration code, so it is possible that in future we also can provide another different registration mechanism with different implementations. So the idea here is that we will provide a flag in a init class ADM init command line to init the OCM hub with AWS-IRSA registration mechanism. And then which means that in this case, the AWS-based registration will be enabled on the hub side. And then on the join command, the user will need to also add a flag with AWS IRSA as a registration process. So they also need to provide additional things like the ARN. The ARN will include the hub cluster account ID, which means that what's a hub cluster, where is a hub cluster, and that ARN will be used for the agent to tell the hub cluster that this is an agent, and then hub can know this is a valid request from the agent, and then use the agent's account ID to assign a certain role to that. So the accept part is just the same, but underneath the command line, there will be some additional thing that will be done in the controller side to call the AWS to create some ARN roles and permissions. And something that is different is we previously in the CSR-based authentication registration process, the hub code config we provide to the agent will be will include the TLS, like the client key and client cert. But in the AWS part, we will the hub code config provided to the client, to the agent, specifically to the work and registration agent, will be something like this. Like you will have the execute command, and that will call the AWS command to exchange the tokens, and then use that token to connect to the hub API server. So this means that in the registration controller or the class A agent, deployment, we also need to embed the AWS command line. So we have some idea that we will have an init container that copy the AWS command to the real runtime containers. To then in the real runtime container, it can run the AWS command. So that's the main thing that we want, the whole proposal would like to achieve. On the hub side, there are some required change. The change on the hub side will include when the hub client side accept hub accept clients field in the managed cluster is set to true from false. The controllers specific for the AWS implementation will need to like to create some roles and based on the ARN from the hub account ID and managed cluster account ID. And we will provide another driver. So currently we have a driver for the CSR registration, and for AWS based, we will provide another driver in the registration agent. What it basically did is to run those commands, like to run the update group config command, and using the role that is provided in the command line at the field provided to the agent. So here is a more detailed flow. Like the first thing that what happens is let me give so there will be several actors that is similar as what we have in the CSR based registration. There will be cluster admin on the managed cluster, that is basically to join the cluster to the ACM hub, and there is IAD admin on the managed cluster. So in general, the actor who is going to join a cluster to the OCM hub will need to have the both cluster admin role and IAM admin role on the managed cluster. So there is also cluster admin and the IAM admin on the hub cluster. And those are the role that's going to accept the hub class, the clusters join on the hub side. So let me give you. So here is some more detailed flow. I'm not sure. I may not go more detail on all the permissions that need to be set on during this this whole process, but here is a flow in a general flow that will happen on the when we use AWS based registration. So firstly, the cluster admin on the managed cluster will still have the bootstrap group config, and that bootstrap group config is still using the token based. But that bootstrap config will not be used for the CSR registration, but only to create the managed clusters, to register the managed cluster onto the hub. And then, so after that, the managed cluster will be created on the agent will create the managed clusters on the hub. At the same time, we need to specify a certain annotations, which is called EKS managed cluster ARN annotations in the managed cluster. So that can be set when the agent is started. So the ARN will include the cluster managed clusters account ID. So then those cluster name and agent name will be put into the hub group config secret. That's just the same as what we did today. And that is consistent for all the registration process. So after that, the cluster admin on the hub cluster need to accept that. To accept that, it will run a cluster admin accept, which means it will change the hub accept a client field in the managed cluster from false to true. This will trigger something including to update the AWS auth code config map in the hub cluster, and then some identities and permissions will be created on the AWS. So it will have a role, specific role for each managed cluster. So each managed cluster will have a role, including the hub account ID, and then there is a hash value for the managed cluster. So this is the specific role for each managed cluster on the AWS. And then it will have some kind of the policies that also be created on the AWS to ensure that this for this ARN. Yes, and then there's we also update the config mapping and this config map the IAM role to the certain group in the hub cluster. So the group in the hub cluster will be this one, and this one is also the one that we set the role bindings in the cluster namespace to allow the agent to access. And this IAM role will be mapped to this cluster role using this config map. So then there are some normal flow like create a namespace, create role bindings in this namespace. That's just the same as the normal process that we did today. And then at step 8, so from 5 to 7, that's just the same as we did today, that we will create role bindings in the clusters namespace to allow the to set the permissions for the agent. And then at step 9, the agent on the managed cluster will know the role because he knows the hub account ID, he knows it knows its own cluster account ID, and it can now starting to use this ARN to get the kube config, basically to get the tokens and use that to update the kube config for itself. And this kube config, since that is bound to the ARN that we created on the hub here, and this ARN is bounded to the certain permission role binding at certain users and in the hub cluster with certain permissions. So this kube config here will be provided to the agent, will have exactly the permissions to connect to the hub. And then the agent on the managed cluster will use the kube config, and then it can use the kube config to starting to do something like manifest work and register, update the cluster status. So in general, that's the whole flow that happens. So certainly it has some kind of requirement that this, for example, this command can only be run in the EKS. So it has some kind of limitations, but it's a very good programs that we can start it to running with a customized registration process, another different registration process, and can start to support the EKS. And something to do. So currently we only support, as I said, it's only EKS and EKS. But if the managed cluster is not EKS, we have to think about another possible way that we could resolve that. And there's also some other thing that gap that hasn't been covered by this proposal is about the add-on registration part. So that part has not been covered by this proposal, but we will starting to consider that after we finish this first step. Okay, I think that's basically everything, and I would suggest everyone to take a look at this one. And if there are anything that need to be updated, any concern, please also update it, push a PR to update this one, this proposal. Okay, any questions?
No, this is really great, Kyujin. So I just want to give a shout out to the community folks who submitted this proposal. It's really, as you can see from Kyujin going over, it's really detailed in, and it's really technical. So it's a great job from the community, and also by the PR reviewers, Kyujin, David, Jujang, and many others that gave really valuable feedback to the community as well. So I think it was a great collaboration, and I'm really looking forward to how we're going to keep proceeding with this. Thank you again.
Thank you.
Okay, if there's no more questions or comments, thank you everyone for joining. See you next time. Take care.
Bye.
Bye.